What makes designing space missions and managing space projects unique compared to planning for any other large-scale project? I'll start with you, Mr. Amr.
Okay. Thank you for hosting us. Space is challenging. We say it, but just to put it in context, what is unique about space missions is that firstly, when you start talking to, let's say, stakeholders, it will depend. It's a scientific mission, it's a commercial mission, and usually space missions are typically coming with a custom solution. It's not something standard that you would do one after the other. So aside from a well-established, let's say, geostationary satellites for communication systems, most of the other missions are very unique and require extensive discussion with the end users on what they expect actually on the mission, and especially if it's a space exploration mission going into other planets, that usually takes a long time and a lot of effort to just identify what is needed from the mission itself. Going into the design of each mission, you end up with having typically the space industry around the globe is limited, and there are not so many suppliers or not so many solutions that are off the shelf. You can just plan and take. Usually you will have to design specific instruments or equipment specifically for your mission, and that takes a lot of cost and a lot of time from, let's say, suppliers and companies. Also, logistics. I mean, you need to reach space. And today, it's challenging, and the access to space is a technology that is very difficult even for well-advanced countries around the world. I mean, there are a few launch vehicles that you can really trust, and it can help you reach your target orbit or your target destination. And with that comes timeline, delays, and potential risks of failures during launch. And a lot of the effort that you have done designing, building your mission will end up, God forbid, a failure mission only in launch. Beyond that, going to space, the space environment is very harsh. So from day one, you have to take into consideration a lot of radiation levels, thermal challenges, communication challenges. Even when the mission is in space, sometimes, and most of the time, you have limited access to your spacecraft, and you have to plan everything ahead of time. And typically, the lifetime of a mission, depending on its design, for LEO 5-10 years, for GEO 20 years, and then for other space exploration missions going to other planets, it could take years and years, 10-20 years just to reach the destination. So the design of these space missions is very unique, most of the cases in every mission, and that's what's really unique about it. That's what I can say from my side, yeah.
Thank you. And Mohsen, what are your thoughts on that?
Yeah, I think nothing more to add to what my colleague Amr mentioned, but maybe a specific example that Jim here gave us last week, that the space is trying to kill you. When you go to space, when you send anything there through spacecrafts, astronauts, the environment, it's trying to destroy you. So when you design things here on Earth in a different environment, and then making the assumptions on what needs to be done so this platform can survive space, that's the challenge that comes with the design aspect. And as Amr mentioned, depending on what is the scope of the mission. If it's a commercialized mission, for example, yes, once you do the first version, the second version, then it becomes a continuous effort just to upgrade that specific system. But that is not the case specifically on what we are trying to achieve and we're aiming for by developing capabilities, by answering scientific questions. So every mission will be unique, and there is no handbook to tell you this is how you design a spacecraft. There are big books, there are experience from individuals and entities and agencies that can give you the lessons learned, but that's what it stops. You get to decide what you want to do with those lessons learned and how you need to implement it now on this new unique mission that you're designing to go to a different planet, a new planet, even if it's the same planet that, for example, Mars, there is no a handbook that tells you how to design a spacecraft for Mars. Moon, same thing, same concept. So it's the challenge again, as mentioned, it's what is it that you're trying to achieve? Is it a science-driven mission? Is it a technology demonstration mission? Once that is confirmed and understood, then you can take risks. So the way we generally look at any space mission is a risk management. You know you're going into a risk, as mentioned as well. One first step is the launch vehicle, which is almost every time is not something you even control. You do your best decision making and trade study on what launch vehicle meets your needs, but then you have to have a trust on the launch vehicle provider that are able to achieve what you want to do. And it's not as simple as choosing a very well-known launch vehicle that have successful stories back to back. I wish it was that simple, but even with those specific cases, when we look at the launch vehicle itself, we look at it as a package, as a spacecraft plus the launch vehicle. How will this solution or how this platform will then be able to work together? And then, as mentioned again, once you go to the space, if it's a new system developed, you're turning it for the first time in the space environment, in a real space environment. You do your best to mimic that environment on Earth from the different environmental tests that you do. But when you go to space, that's when the real test happens. And that's when you turn on the spacecraft for the first time. And that's when you will know how good is your design. You hope it's a software update that can fix it. But normally, which is the norm again, that at a first operational phase, you get to fix some of the softwares that you've done. But you make sure you don't have any hardware change that needs to be done in space.
So you both mentioned that space mission design is constantly changing, and you're tailoring it to your specific mission and your specific needs. Unless something is commercialized, you're constantly flying something new to space, to this very harsh and unpredictable environment. So for the UAE, how is space mission design done differently based on your experience of working on space missions locally compared to what is done internationally, and why is it different, Dr. Mr. Amr?
Well, the UAE has taken a decision to consider space as a strategic sector for the country's future. So instead of taking it as a luxury, it's a necessity. And with that came an aggressive amount of ambition as well as targets to make space really a main pillar of our economy, our social life, and a driver for science and technology in the UAE. With that came a rapid growth of how the UAE considers space missions. So I think we started off back in the 90s with commercial communication systems, but back in 2006, when MBRC was established, and beyond that, the establishment of commercial companies, from Mubadala, YASA, to the space agency, to regulations, to space exploration. With that came a lot of rapid growth of our adaptation of space projects. Space projects, but we have missions not only for Earth observation, now we have lunar exploration, Mars exploration, and now even the UAE is partner with international collaboration to build a station around the moon. And that all takes us to eventually maybe go and explore Mars and live on Mars. That kind of pressure, let's say, and ambitious strategic objectives requires a different way of designing your missions. So one day you are working on a satellite that will go around Earth, taking images. Another day you will be planning to send a probe to Mars, and then beyond that sending a rover to the moon. So the adaptation of, let's say, a methodology to design the missions changes with every one of them. And I think the UAE has a unique, let's say, team, whether it's in MBRC, space agency, in commercial companies. We have very unique, enthusiastic team that is excited about space. The whole country is excited about space. So that makes us want to go faster, want to grow faster, and take mission design in a different perspective. If we do actually shorten a lot of time when making decisions, technical or in terms of management, and we have really clear communication with the leadership, with the end users, and I think that helps us a lot in making decisions faster. And as we go in our development, the UAE has a well-established, let's say, communication and let's say geopolitical stand globally, so that facilitates a lot of our, let's say, communication with other agencies or other companies around the world. You cannot do missions alone, so you have to have a real good relationship with all over the world. So I think this helps us in when we design our missions. You know, if you want to decide whether I buy this system or that system, it's easy when you have many choices. Different than when you have a single choice and you have to design around it. So I think that stand of the UAE makes us very unique, I would say.
Mr. Mohsen, what are your thoughts on the UAE's approach to space missions?
Yeah, I can't agree more with the statement Amr was just mentioning. And also, one luxury I would call that we have in the UAE is we look into tailoring what works for us. So we get access to best of the capabilities that's available from the east to the west. We work with collaboration on collaboration missions. We learn from them, and then we try to see what fits our agenda, what fits our standards, what makes more sense for us. And the beauty, as well, that was mentioned in a couple of sessions ago, we don't stick to one standard for a long time. We adapt to it. We're not changing it every month or so, no. We whatever is working for us, we will continue with. And if we found there is something better that we have missed, if we need to adapt to that, let's see what would it take to do that. And we need to be comfortable to be able to make big risk decisions, or risky decisions, let's say. But again, I think it's the way we do things is different in the point of the view that we're a young nation. You know, we just celebrated the 50th year anniversary of the UAE a couple of years ago. And NASA, for example, I think is celebrating their 60th anniversary sometime soon, or maybe they did already. What I'm trying to say is we need to catch up to what has been done. And if we follow the normal process of, you know, taking our time with making comfortable decisions through the normal process, that's definitely something we don't do, and we don't have the luxury of as well. And the need of space missions, we understand that is not only for space, but what does it bring to the UAE? And maybe a fair statement I can make here as well. Amr, I was his student. Today, I'm on the same panel with him because of the space missions, because of the sector is creating leaders, because we want individuals to be capable. So if we do it again through the normal process, that can happen, but it might take 10, 20 years. We want to see how we can shorten all of that so we have more capable individuals that are coming out of these missions that are benefiting the science point of view of the country, plus capable individuals and leaders of the sector.
Thank you both. That brings us to the end of our session today. Thank you for sharing your insights.
Thank you.
Thank you.
Thank you, everyone.
Thank you.